IU question set number 3. Question from 2016, number 14 says, state the limit definition of the derivative, and it says the derivative at a. We know that that's the limit as h goes to 0 of f of a plus h minus f of a over h. Then it says use it to find the derivative at 2. So find the derivative at 2. Well, that's going to be the limit as h goes to 0 of f of 2 plus h minus f of 2 over h. So in this case, if f of x is equal to x squared, then what happens is we would have x, again, don't drop the limit yet, h goes to 0, we would have 2 plus h, all that stuff squared, minus 2 squared over h. So it's going to be the limit as h goes to 0. All of this is going to be 4 plus 4h plus h squared minus 4. If you want to come over here on your scratch paper to be more careful, this squared is just this times this. So you're going to get 4 plus 2h plus 2h plus h squared, and that's where we get all this. These cancel out, and we end up getting this. Limit as h goes to 0 of, you're going to factor that out. So since that's equal to 1, this ends up going to 4. Okay. That's that, but now it wants us to do the same thing and find g prime at 1 if g is absolute value of x. Well, that's going to be, again, the limit as h goes to 0 of what? G at 1 plus a little bit minus g at 1 over h. So if g of x is equal to absolute x, we'll notice that as long as you're over here near 1, absolute x is just equal to x for x positive, and it's negative x for x that's negative. So since we're over here near 1, I'm just going to replace this with 1 plus h. So in other words, the function x. And over here, I'm going to replace it with x as well. So I just get 1 over h. So you're going to take the limit as h goes to 0. And those are going to cancel out. You're going to get the limit h goes to 0 of h over h. That's just 1. And so you're going to get the limit as h goes to 0 of 1, which is just 1. And we expected that. 2019. So then 2019, question 11, a 6-point question. It says, find the derivative at 1. Well, I know that's going to be the limit as h goes to 0 of f of 1 plus h minus f of 1 over h. But in this case, f of 1 plus h on my scratch work, if I'm using the function square root of x plus 3, it's going to be 1 plus h plus 3. So it's root 4 plus h. But f of 1 is going to be root 1 plus 3, which is root 4, which is 2, all over h. So then this looks like a limit problem that we've done before, where we use our old friend the conjugate, where I just change the middle sign, but use the same thing on top and bottom. So it's root 4 plus h. It's root 4 plus h. So you're going to end up getting 4 plus h minus 4 over h. 4 plus h plus 2. These go away. You're going to get the limit as h goes to 0 of. Factor this out. You're left with this over this. So then, since that's equal to 1, you're left with 1 over root 4 plus h plus 2. As h goes to 0, you get 1 over root 4 plus 2, which is a quarter. Great work.